Magandang araw mga kasipnayan! Welcome to Sir Ocnic's YouTube channel. In this video, we are going to generate patterns, define a sequence, and identify terms given a recursive formula. To start off, let us identify the missing pieces of beads in the following patterns. What do you think is the missing bead on our first example? Very good. That's an orange circle bead. How about on our next example? The next bead is a red-orange elongated bead. On our third example, the missing bead is a blue-green circle bead. How about on our fourth example? The missing bead is a green circle bead. And on our last example, the missing bead is a blue circle bead. Before we start, let us define a pattern. A pattern is a series or sequence that repeats. Math patterns are sequences that repeat based on a rule, and a rule is a set of ways to calculate or solve a problem. Each number in the sequence is called a term. There are two kinds of sequence. The first kind of sequence is what we call a finite sequence. A finite sequence is a list of terms in a specific order. The sequence has a first term and a last term. The order of the terms of a finite sequence follows some type of mathematical pattern or logical arrangement. Here are some examples of a finite sequence. 4, 8, 12, 16, 20, and 24 is a finite sequence with 6 terms, having 4 as the first term and 24 is the last term. 10, 5, 0, negative 5, and negative 10 is a finite sequence with 5 terms, having 10 as the first term and negative 10 as the last term. 4, 10, 18, 28, 40, 54, and 70 is a finite sequence with 7 terms, wherein the first term is 4 and the last term is 70. The second kind of sequence is what we call an infinite sequence. An infinite sequence is an endless progression of discrete objects, especially numbers. The three dots, which is called an ellipsis, is placed after the last term, which signifies that the sequence has no end. Here are the examples of an infinite sequence. 4, 6, 8, and 10. 24, 18, 12, 6, 0. 0, 1, 3, 6, 10, 15. The sequences above are infinite because of the three dots called ellipses, which signifies that it has no end. Let us now identify the next three terms of the given sequence and give the rule. Number 1, 4, 7, and 10. The rule is you just add 3. The next three terms are 13, 16, 19. Second example, 6, 3, 0. What do you think is the rule? The rule is you just subtract 3. The next three terms are negative 3, negative 6, and negative 9. Third example, 12, 10, 8, and 6. What do you think is the rule? The rule is you just subtract 2. Therefore, the next three terms are 4, 2, and 0. Fourth example, 10, 2, negative 6. What do you think is the rule of the sequence? The rule of the sequence is you subtract 8. Therefore, the next three terms are negative 14, negative 22, and negative 30. On our fifth example, we have 18, 22, and 26. The rule is you just add 4. Therefore, the next three terms are 30, 34, and 38. On our last example, we have 7, 14, and 21. What do you think is the rule of the sequence? The rule is you just add 7. Therefore, the next three terms are 28, 35, and 42. Let us have another activity called Follow the Rule. Let us use the starting number and the rule to determine the next three terms. To start off, we have 12 and use the rule add 4. So the starting number is 12 and let us add 4 to identify the next three terms. The numbers would be 12 plus 4, 16, 16 plus 4, 20, and 20 plus 4, 24. Therefore, we have 12, 16, 20, and 24. Second example, start with 18 and use the rule subtract 5. The numbers are 18, 13, 8, and 3. Third example, start with negative 7 and use the rule add 11. We will then have negative 7, 4, 15, and 26. Fourth example, start with negative 13 and use the rule subtract 6. The sequence will be negative 13, negative 19, negative 25, and negative 31. Start with negative 7 and use the rule subtract negative 3. The sequence will be negative 7, negative 4, negative 1, and 2. Let us now define an arithmetic sequence. An arithmetic sequence is a sequence of numbers such that the difference of any two successive members of the sequence is a constant, which is called as the common difference. In here, we have two kinds of sequence. We have the increasing arithmetic sequence on the left side and a decreasing arithmetic sequence on the right side. Under increasing arithmetic sequence, the common difference is positive. So we have 5, 9, 13, and 17. The common difference in this sequence is positive 4. Under decreasing arithmetic sequence, the common difference is negative. We have 20, 17, 14, and 11. The common difference in this sequence is negative 3. We can represent an arithmetic sequence using a formula. We can directly compute any term of the sequence using a formula. A formula describes a way of finding any term in the sequence. There are two types of formula in an arithmetic sequence. We have the recursive formula and the other one is the explicit formula. A recursive formula gives the value of a specific term based on the previous term, while an explicit formula gives the value of a specific term based on the position. For now, Let us identify terms in a recursive formula. Find the first four terms of the sequence a sub n is equal to n plus 7. So since we are going to find the first four terms, we may then have a sub 1, a sub 2, a sub 3, and a sub 4. By substituting the value of n in the given formula, we will then have 1 plus 7, and that is equal to 8. Therefore, a sub 1 is equal to 8, or the first term in the sequence is equal to 8. Let us now solve for a sub 2. Substitute 2 to the value of n in the given formula. We will then have 2 plus 7. Therefore, a sub 2 is equal to 9, or simply, the second term of the sequence is equal to 9. Let us identify the third term by substituting n by 3. We will then have 3 plus 7. Therefore, a sub 3 is equal to 10, or the third term of the sequence is equal to 10. Let us now have the fourth term of the sequence by substituting the value of n by 4, and that would be 4 plus 7, which is equal to 11. Therefore, our fourth term of the sequence is equal to 11. We therefore conclude that the first four terms of the given sequence a sub n is equal to n plus 7 are 8, 9, 10, and 11. Let's have our second example. Let us find the first four terms of the sequence a sub n equals 3n minus 5. Since we are going to find the first four terms, we will then have a sub 1, a sub 2, a sub 3, and a sub 4. By substituting the value of n to the number of terms, we will then have for a sub 1, that is 3 times the value of n, which is equal to 1, minus 5. And that is equal to negative 2. For our second term, we will have 3 times the value of n, which is equal to 2, minus 5. We will then have a sub 2 is equal to 1. For our third term, we will have 3 times the value of n, which is equal to 3, minus 5. We will then have a sub 3 is equal to 4. For our fourth term, we will have 3 times 4 minus 5, which is equal to 7. We therefore conclude that the first four terms of the sequence are negative 2, 1, 4, and 7. Let us find the first three terms of the sequence a sub n is equal to 2n squared minus 3. So since we are going to find the first three terms, we will have a sub 1, a sub 2, and a sub 3. For a sub 1, that would be equal to 2 times the value of n, which is equal to 1 squared minus 3. Simplifying the exponents, we will have 2 times 1 minus 3, which is equal to negative 1. For our second term, we will then have 2 times the value of n, which is equal to 2 squared, minus 3, which is equal to 2 times 4 minus 3. Simplifying the equation, that will be a sub 2 is equal to 5. For our third term, we will have 2 times the value of n, which is 3, squared, minus 3. Simplifying the exponents, we will have 2 times 9 minus 3, which is equal to 15. Therefore, the first three terms of the sequence a sub n is equal to 2n squared minus 3 are negative 1, 5, and 15. Let us find the first three terms of the sequence a sub n is equal to 2 raised to n plus 5. So we have a sub 1, 2 raised to n, which is 1 plus 5. Simplifying the exponents, we will have 2 plus 5, which is equal to 7. For our second term, that will be 2 squared plus 5. That is equal to 4 plus 5, which is equal to 9. For our third term, we will have 2 cubed plus 5, which is equal to 8 plus 5, which is equal to 13. We therefore conclude that the first three terms are 7, 9, and 13. Let us find the first, fourth, and ninth terms of the sequence given a sub n is equal to 2 square root of n minus 1. So for our first term, we will have 2 times the square root of 1, which is the value of n, minus 1. And that is equal to 2 times 1 minus 1, which is equal to 1. For our fourth term, we will have a sub 4, which is equal to 2 times the square root of 4 minus 1. Simplifying the radicand, we will have 2 times 2 minus 1, which is equal to 3. For our ninth term, we have a sub 9. Substituting the value of n, we will have 2 square root of 9 minus 1. Simplifying the radicand, we will then have 2 times 3 minus 1, which is equal to 5. Therefore, a sub 1 is equal to 1, a sub 4 is equal to 3, and a sub 9 is equal to 5. Let us now summarize what we have discussed in this video. A finite sequence is a list of terms in a specific order with an exact number of terms. An infinite sequence is an endless progression of discrete objects, especially numbers. A recursive formula gives the value of a specific term based on the previous term, and an explicit formula gives the value of a specific term based on the position. Let us now check your knowledge. Do not forget to pause the video while you are answering the next activity. I think you are now ready to check whether your answers are right. Find the first three terms of the sequence a sub n is equal to 3n squared plus 7. For our first term, we will have 3 times the quantity 1 squared plus 7. Simplifying the exponents, we will have 3 times 1 plus 7, which is equal to 10. A sub 2 will now be 3 times quantity 2 squared plus 7. Simplifying the exponents, we will have 3 times 4 plus 7, which is equal to 13. A sub 3 will be 3 times the quantity 3 squared plus 7. Simplifying the exponents, we will have 3 times 9 plus 7, which is equal to 16. Therefore, the first three terms of the sequence are 10, 13, and 16. Find the 16th and 25th terms of the sequence a sub n is equal to 3 times the square root of n plus 7. For a sub 16, we will then have 3 times square root of 16 plus 7. Simplifying the radicand, we will have 3 times 4 plus 7, which is equal to 19. For the 25th term, we will have a sub 25, which is equal to 3 times the square root of 25 minus 1. Simplifying the radicand, we will have 3 times 5 plus 7, or simply equals 22. Therefore, a sub 25 is equal to 22. Thank you for watching Sir Ocnic's YouTube channel. If you think that this video is a big help, hit like, feel free to share, and do not forget to subscribe. Again, this is Mr. Cinco saying, enjoy learning, goodbye, and God bless.